Thank you for the opportunity to present on OBIS, the Ocean Biodiversity Information System, which runs under the auspices of UNESCO's Intergovernmental Oceanographic Commission, or IOC. I am Ward Appeltans. I'm the head of the International OBIS Secretariat. The IOC was established by UNESCO in 1960. The IOC is a body with functional autonomy, which means that we have our own governing body, the Assembly, with 150 member states. The IOC can be seen as the ocean science body in the United Nations system. We are competent for marine scientific research, capacity development, and transfer of marine technology. We are also the custodian agency within SDG 14 and more specifically responsible for Target 14A and 14.3. The IOC is also coordinating the UN Ocean Decade. OBIS started in 2000 under the Census of Marine Life program and was adopted by IOC in 2009. So for 22 years now, we have been building a central global data platform that provides free access to the world's ocean biodiversity and biogeographic data. The IOC member states recognize OBIS as the global open access data and information clearinghouse on marine biodiversity for science, conservation, and sustainable development. We provide access to more than 100 million observations of 164,000 marine species, from bacteria to whales, integrated from over 4,600 datasets. We see an explosion of new data, and since the last 2 years, since the COVID pandemic started, we added 50 million new observations. That is the same amount of data that we have been able to publish in the previous 20 years. This graph shows the amount of records per ocean volume and by time, starting from 1800. Of course, there's more data from the surface of the ocean, but since the 70s and since the discovery of the deep sea vents, which are unique chemosynthetic ecosystems, there are more and more observations from the deep sea. And you can clearly see the explorations to the deepest parts of the ocean, like the Mariana Trench, which is 11 kilometers deep. Or, for example, the data gap during the Second World War. Beyond just species presence and absence, we also provide data on habitats, abundance and biomass, migration routes through tracking animals, and more recently also occurrences based on DNA sequencing. OBIS supports international collaboration and provides access and benefit sharing, which is illustrated here. You can see the country affiliations of the researchers that have collaborated together on publishing research papers using data from OBIS. And every day there is a new paper coming out. However, this graph showing the same data also highlights the digital divide. There are less papers published by developing countries, and the north-south and south-south connections are still too weak. We contribute to many international and UN-led assessments. However, detecting and reporting the change that is happening now is still in its infancy, and we remain mostly at the level of biodiversity description. Or in other words, we have not yet managed to develop a system that systematically monitors the change of biodiversity, a system like we have for monitoring and predicting the weather, for example. The amount of data in OBIS sounds amazing, but this is still just the top of the iceberg. In a recent study, a survey of around 200 long-term biological observing programs revealed that only half of them store their data in a long-term data repository, and only a quarter provide public access to their data. The most common argument is that they don't know how to standardize and publish their data in data repositories, or there are no resources to cover that extra step. With the Global Ocean Observing System, or GOOS, another program of IOC, and in partnership with MBON, we are working on a 10-year roadmap to build a global ocean biodiversity observing system that feeds the right information into the many assessments and policy frameworks, such as the post-2020 Global Biodiversity Framework, currently under negotiation at the CBD. This roadmap goes from developing the specifications and protocols to implementing new and innovative technologies and building capacity on the ground. This process for ocean biodiversity does not run in isolation, but builds on 30 years of experience in the physics domain, which now feeds data into the Global Climate Observing System, which was established already in 1992. So for biodiversity, we're at least 30 years behind the climate system. Training and developing capacity is essential, and creating this human connection is key to reaching our goals. Data management is often something that you learn on the job and is not taught at most universities. We're also developing forces in the field, like setting up an early detection system for marine invasive species in Fiji using environmental DNA. The data processing and bioinformatics pipeline is provided through our global OBIS system, so small island states do not have to invest in this data infrastructure. We recently partnered with the World Heritage Center to organize a big citizen science campaign to monitor biodiversity using environmental DNA in marine World Heritage sites. And we'll have 25 expeditions across the world in the first pilot phase of this program, which is sponsored by the Flanders government of Belgium. With good teamwork, we can make it happen. And I wish to thank the sponsors for their financial support. I want to thank the many scientists who share their valuable data and all the data managers at the national and regional OBIS nodes for processing the data before we ingest it into the global system. Thank you.